Okay, so we still have one more example. This is still using a calculator to find theta. And this time secant theta is equal to negative 2.6. First of all, let's just remind ourselves of where we're going. So secant is also, let's just recall real quick, secant of theta is equal to the same thing. This is equivalent to cosine of theta. What's the reciprocal of this? Negative 1 over 2.6, right? So just do the reciprocal and then keep the negative out front. Now, where is the cosine theta negative? Well, if it's positive here and here, that means it's negative here and here like the previous one. So secant of theta is negative in these quadrant 2 and quadrant 3 as well. So at this point, let's use our cosine inverse property times cosine theta. Take the cosine, multiply both sides by the cosine inverse. And then cosine inverse times cosine is just going to be theta is equal to, go to your calculator here. Remember, we don't have a secant button in the calculator. So our option is to use that relationship, reciprocal relationship, to be able to use the calculator. Okay, so when we plug that in, we're going to get approximately 1.96559. So I'm going to leave the entire thing this time, 1.96559. If you seem to be missing these in my math lab, maybe it's because if you round too early, it's going to count to every decimal place. So it's probably safest to save the rounding to last. So this is cosine inverse we're working with. Cosine inverse is just the top half of our unit circle, right? So that's this angle. We still have one more. Okay, so we'll do that 2 pi minus that to get the other one. So for the theta in quadrant 3, we will take 2 pi and subtract out, which is approximately 4. Okay, is 4.32. So the two solutions are 1.97. This is round to 2 decimal places, and 4.32. Like I said, in my math lab, it may be best to save the rounding to the last step, but okay, so now we're going to move to solving trig equations using identities. Specifically, they tell us to use identities. So we know we're going to be doing that, but let's just, what do you not like about this other than it looks pretty complex? What else? They're not all the same trig function. So this is sine theta, and then this one's cosine squared theta. So the first thing we want to do is be able to rewrite the function using identities so that it contains only sine values in this case. So we have some trig identities. Let me pause it for a second. Okay, so we pause it. Here's your Pythagorean identities. We need one with sines and cosines. Well, it's clearly the first one. And cosine squared is more difficult to deal with, so we want to replace this one. So I want to replace cosine squared. Well, I need to take this equation, sine squared theta plus cosine squared theta, and get cosine squared by itself. So if I want to get cosine squared by itself, I'm going to subtract sine squared theta. Whatever you do to one side, do to the other. So basically, cosine squared theta is equal to 1 minus sine squared theta. So in place of this, what do you think we're going to put? 1 minus sine squared theta. Good. So first of all, I'm just going to rewrite this left-hand side. And in place of cosine squared theta, I'm going to put 1 minus sine squared theta. Let's just distribute and simplify this other side. So we're going to have 3 plus 3 sine of theta. I'm just leaving that side alone. Now let's distribute here. 6, and then that's going to be minus 6 sine squared theta. All right, our next step is we want to move everything to the left and get 0 on the right so we can have something equal to 0. So I'm going to subtract 6 from this side, and I'm going to add 6 sine squared to the other side. And then I'm just going to put those in order. So I'll have positive 6 sine squared theta on this side. Okay, then I'll have 3 sine of theta. So my first one was when I moved this one over. Then I have this one. Now if I subtract 6 over here, what's 3 minus 6? Negative 3. Okay, so one more time, let me say where I add 6 sine squared to both sides, so that would give me a positive. I bring this one down, subtract 6, let me just show that. So if I were to subtract 6 from both sides, 3 minus 6 would give me a negative 3 on this side. Okay, so now I have my left-hand side, and it's something that can be factored. Now that's hard, maybe hard to see, so if I was to come off to the side and scratch work, okay, and everywhere that there's a sine theta, I'll let that be x. So let's say that would be 6x squared plus 3x minus 3 equals 0. That looks more familiar to us, right? Okay, now what's the first thing we would do over here? They have a common factor, so let's factor out a 3? So this would be a 3x squared plus x minus 1 equals 0. Now, what multiplies to give us negative 1 adds to give us a positive 1. If I use bottoms up method a lot of times, so what multiplies to give you a negative 1 adds to give you a positive 1, which would be what? Except for that doesn't work. And that's because I left this out. So what would that be? Yeah, 2x squared. That makes more sense now. So now bottoms ups would be what multiplies to give you 2 times negative 1. So what multiplies to give you a negative 2, but when you add them, you get a positive 1. What would that be? Multiplies to give us the outside, negative 2, but when you add, you get positive 1 inside. So 2 times negative 1 is negative 2. 2 plus a negative 1 is a positive 1. So these two factors satisfy our bottoms up. So what the next step is to put them over the first term, over a 2x, and then you put this one over the first term, and then you reduce. This divide by 2, so that's just going to be, there's a 1 there and a 1 on the bottom. So when we write from the bottoms up, this is just going to be x plus 1. Over here, nothing reduces on this fraction, so we write from the bottom up, and that's going to be 2x minus 1. Now this is factoring using bottoms up method. You can use whatever method you like. This is just one suggested. Now, our problem, this is what we use to help it look familiar. In place of x, we have a sine value, so we're just going to mirror this over here. So the first thing we did was we factored out a 3, and that gave us 2 sine squared theta plus sine of theta minus 1 equals 0. Right? So now everywhere there's an x, we're going to put sine squared or replace it with sine. Alright, and then our solution is going to be down here. So x plus 1, when we come over here to the left, is going to be, if we have that, that's going to be sine of theta plus 1. And what's the other one going to be? 2 times the sine of theta minus 1. Okay, so all I did is I took my factored form here, and everywhere there was an x, put a sine of theta. Sine of theta plus 1 2 sine of theta minus 1. Just carry down my 3. This is set equal to 0. Now to solve this, when you set 3 equal to 0, you have no variable, so that's just going to be gone. Set this one equal to 0, and then we're going to set this one equal to 0. So the first one is sine of theta plus 1 is equal to 0, and the second one we want to solve is 2 times the sine of theta minus 1 is equal to 0. And recall, when I set 3 equal to 0, there's no variable, so it just loses value. There's no value to it. Okay, so now we're just solving. So subtract 1. Where is the sine of theta equal to negative 1? So here you would go to your unit circle, and where the y value equals negative 1 occurs at what? 3 pi over 2. Yeah, so use your unit circle to find that. And then we move over here, so we're going to add 1 to both sides. 2 sine of theta is equal to positive 1, and then we divide both sides by 2. So for this one, we want to know where the sine of theta is equal to positive 1/2. Well, go to your unit circle. Sine of theta is positive 1/2. That's the y value equals 1/2. It occurs at what places? It occurs at pi over 6 and also 5 pi over 6. So our solutions that satisfy this original equation are going to be 3 pi over 2, pi over 6, and 5 pi over 6.